Hi. Now let us have some more in-depth discussion about the correlation between two variables. As I mentioned earlier, we have two data sets, two variables. One is the outer diameter measurement in x direction, and another is outer diameter measurement in y direction. So there are 5 points measured, and for each point the OD of in x direction was measured and OD in y direction was measured. So how we define or estimate the correlation between the two variables? Well, first we have to calculate the covariance between those two variables, and then the normalized value of the covariance will be the correlation coefficient. I have presented the formulas for covariance and for correlation coefficient. So one could substitute the values of ODs for both data sets into the formula and receive the value of correlation. Basically, I did some preliminary calculation, and I have received the value of minus 0.097. The value of correlation could vary from -1 to +1. When 1 is a strong means strong positive correlation, -1 means strong negative correlation, and 0 no correlation between two variables. Okay, let's plot the data set. That will make more sense as far as the presentation and explanation. Okay. So we have for point number 1 we received 68 thousandths of inch in x direction and 68 thousandths of inch in y direction. Let's do some plotting here. So it will be data point over here. These are the x coordinate system as axis, and this is y axis, which represent OD in x direction and OD in y direction. Okay, 69 in x, 67 in y. Okay. 70 in x and 66 in y. So you see the picture? 67 in x and 69 in y. And 66 thousandths in x direction and 69 in y direction. Oh. Sorry. Okay. So we see when value of OD in x direction increases, the value of OD in y direction decreases. So basically the graphical output indicates to a strong correlation. Since the OD in x direction increases and OD in y direction decreases, we have a negative correlation, so strong negative correlation, and it's no doubt that, and it's not basically it's not a surprise that we received 0.97 as an output of our calculation, and with the lowest value being -1, we almost received an ideal correlation between those two variables. And it does make sense, because catheter being almost a rigid body, if you have a change in one direction, that will basically impact the dimensions in another direction. So, and if, for example, this scatter plot would have showing this type of diagram, basically this indicates that there is no correlation between the x variable and y variable. So certainly looking at the graph you can tell whether there is a correlation or no correlation. And I would like also the speak about the correlation and causation. Certainly we do see that while OD in x direction is changing, the OD in y direction is also changing, but we are not positive that the change in x direction is causing the change in y direction. It just there is a process related issue when catheters are being formed in the ovens, so that's what the process settings of the oven causing this change in both directions, but not certainly not OD in x direction is causing the OD in y direction to be varied. That was important difference between causation and correlation I wanted to convey to you. And also as a homework and for seminar learning plan 2, I would like to get a plot of the correlation between two variables of your choice, just to have you practice using any software. And again, my goal as an instructor, I would like you to get familiar with any software which will help you in your future analysis and research outside of this class. Okay, thank you for your attention. Have a nice day. Bye.